if I talk for more than 30 seconds, just reach over and slap me. Nobody wants to see me talk for more than 30 seconds. I'm Justin Mart.
And I'm Katherine Wu.
Well, we are doing something new this week. We have no guest. So it's just you and me.
Just you and me.
I know. What a wonderful world. We are also going to be addressing one of the most challenging topics to discuss. The reason why we don't have a guest is because, I don't know, I just think it's really challenging to find a guest that can be impartial in this. Because we're talking about the universe of Ethereum and Ethereum-like chains.
We are talking about the universe of blockchains.
Oh boy. You would joke that it's not a very sexy topic. I think it's sexy, but this is our little dynamic here, so it's good.
Yep. Great. Can't wait.
Oh boy, here we go.
One of the things that really made me realize just how confusing it is, obviously this year I've won the battle, right, around the dinner table. People are downloading Coinbase, they're ready to buy their first crypto assets. So yes, that's a win for me. But very quickly I realized it's actually not a win for me at all because, oh my God, now I'm the spokesperson for the industry. And it is so confusing because here's the thing. This is a really common scenario that comes up. So my friend downloads Coinbase. She comes to me, she's like, hey, wow, I didn't realize there were so many little coins and things aside from Bitcoin. Like, what are all of these names, right? She points her phone in my face. What are all these? Are these all coins? Are these all like Bitcoin? What is
How are they supposed to know?
Ethereum?
Yeah.
Right. And what do they all mean? And I'm like, oh gosh, should I sit you down, right, and give you a whole course? And I think this is a little bit of what we're trying to do today.
That's what we're trying to do.
Yeah. Actually, in the future, I'm just going to send this exact podcast to my friends. But understanding the difference between the token, which is probably what you see on exchanges, and their underlying protocol or their underlying technology. And that underlying thing is what I want to get into today.
Yeah. And this is also where it's confusing. Because if you just think about it for just take the example of Ethereum, you have Ethereum, the blockchain, which plays host to all these different applications, and there's all these tokens that live on Ethereum, right?
Yeah.
And Ethereum is also a token itself. It lives on the Ethereum blockchain.
Yeah.
So the naming conventions here are super challenging. And to your point, it's look, when people open the Coinbase app, what are they looking at? How are they supposed to know what they're looking at?
Yeah.
Even if they recognize, oh, we're talking about a layer one blockchain, whatever that means, we'll talk about in a second. How are they supposed to think about that blockchain's viability and long-term strengths and, what they're trying to accomplish and how it relates to Ethereum itself?
Yeah.
And what the dynamic is.
And I think my goal for the end of this conversation is to empower any listener out there just to be able to parse through some of the keywords in the description. And you're like, aha, these are the buzzwords that I learned from Justin and Katherine. And here is how I should think about it. So let's jump into it. Let's break down these keywords.
I mean, we only took 5 minutes to explain what topic we're talking about, right? So
this should be super easy.
I know, it should be so easy to get into the topic now.
All right. So I think the first buzzword I want to talk about is layer one.
Yeah.
Okay.
A layer one is just the blockchains. We're very descriptive in blockchain land. We're so creative. We come up with the word layer one, right? But it basically means an independent blockchain that exists by itself, that knows of nothing else, is just trying to reinvent the blockchain ecosystem from its fundamental base principles to create, hopefully, something better. So it is the base fundamental layer in an application stack. It is a layer one system.
Yeah.
The examples here would be Ethereum, Solana, Polkadot, Cosmos. Insert your other favorite blockchain here, right? Layer ones can be doing many different things. Bitcoin is layer one.
Layer one is the base technology that allows different kinds of applications to be built on top of it.
Yep.
Right? So crypto companies or crypto apps are really just apps that build using the blockchain infrastructure.
Yep.
And there are different types of blockchain infrastructure.
Yes.
That is layer one. That is our foundation, right? That powers whatever crypto app, company, what have you.
And to make it even more, hopefully not confusing, but we're actually also restricting ourselves to only layer ones that let you build applications. These are smart contract systems, right? That's why we're not talking about Bitcoin. Bitcoin today doesn't have smart contract capabilities. Maybe it will in the future, who knows, yada, yada, but doesn't have it today. So do a lot of other layer one blockchains. They're not necessarily trying to do smart contract systems. So this is clearly Ethereum, the universe of blockchains that lets developers build applications on top of them.
So one huge question I want to ask is, why is there more than one underlying blockchain? We have Ethereum. Why do we have all the other ones? And I think what that points to is this concept called the blockchain trilemma.
Yeah. It's a bit of a buzzword as well. So we're hitting on another buzzword in crypto. But yeah, it's like Ethereum already has so much developer mindshare, so much network effect, so many users on it. It's like, why would anybody try to compete, or why would anybody try to actually improve on that or make something different from that, right? Why doesn't it just win?
Yeah.
Well, there's a theoretical challenge that's been proposed to the blockchain community. We think that a blockchain can only choose 2 of 3 things.
And this is the blockchain trilemma.
And this is the trilemma,
okay, you're defining
right?
it
Exactly.
now. Great.
So you can either be secure in the sense that transactions will land as they are written. There's not going to be any funny business going on. The blockchain can handle, a lot of value flowing through it without anybody trying to, mess with that, right? The other leg of the trilemma is decentralization. It's a decentralized system. There's many different people part of that system helping push it forward. There's no single actor in control of it. And the third one is scalability.
Yeah.
How many transactions can a blockchain process per second, per minute, per whatever?
Yeah.
And so the reason why it's a challenge, right, just to kind of lay it out a little bit, is if you want high throughput and high scalability, well, it's very, very challenging to process that much information through a blockchain if a ton of different people have to be party to that exact ecosystem at the same time. So if you increase the throughput, it's really hard to have a large set of people be fundamentally responsible for pushing that ecosystem forward. And that those 2 factors also affect the security of the blockchain in the sense of how secure is it from people trying to manipulate it or steal from it or break it. And so postulated that you can pick 2 of the 3 and you cannot have all 3.
This reminds me, just to make it a little bit fun for now, this reminds me of the trilemma I had as a college student, which basically is choose 2 of 3, a social life, sleep, and GPA.
Yeah.
Right? Is it theoretically possible to get all 3? Yes. But most of the time, for most students, you're kind of only getting to 2 out of the 3.
Exactly.
Right? If you have a social life and a good GPA, you're not sleeping. If you're sleeping and you have friends, you probably don't have a good GPA, right? So that's like the more fun way to look at this blockchain trilemma, which is that like if you want to be scalable, which is that if you want to be able to handle a lot of volume, you also want to be decentralized, then maybe you're compromising a little bit on security. Whereas if you want to focus on being super secure and you want to focus on being super scalable, then you're probably going to be a little bit more centralized, right?
Yeah, and the reality of this conversation too is that these topics run very deep. Like the rabbit hole goes insanely technical, goes insanely deep. We're not here to talk about all the technical aspects of it. We just want to explain some of the reasons why and how to think through these ecosystems. So that's as far as we're going to get in the trilemma. But it's postulated that, hey, there's challenges here. Blockchains are going to struggle at creating all 3, right?
Yeah, I think this is a good framework. Scalability, decentralization, and security. So maybe the first thing to jump into is the scalability.
Scalability just references how many transactions you can process on the blockchain. One analogy for this is Visa. Think about the card network. Well, it's just one company. And so they're kind of like a single choke point or whatever, but they've got a bunch of computers. They can run 70,000 transactions per, I think, minute or second or whatever it is. It's some high number, right?
Yeah.
And so you look at blockchains, well, it simply references how many transactions they can process per second. So technically speaking, if you have a broad set of people that are running a protocol that are all part of like the mining system to verify a transaction, and you want to have high throughput through that system, you actually can't have decentralization. The technical barrier here is that if you have a ton of transactions, you're processing a lot of data. And a lot of data then goes through a single node on the computer. That computer has to be a specialized computer. It has to be basically a supercomputer that runs really fast, has a ton of RAM, a ton of memory, and that supercomputer prices out a lot of people. Suddenly, only people who can afford a supercomputer can be a node on the network. Suddenly, you're putting artificial restrictions. Even though anybody can, the reality is not a lot of people can actually obtain a supercomputer. And so you're actually limiting the set of people that can participate in the blockchain ecosystem if you juice scalability to its like biggest degree. It's really important because if we think about the internet of money, the ability to have decentralized applications, we want the whole world to be able to access these things in a cheap, efficient manner. And if you can't have high throughput, suddenly, let's say your blockchain only handles 10 transactions per second, and you have enough people that want to post 20 transactions per second, well, suddenly there's a fee market that appears, and only the people that pay a high dollar value per transaction get into the blockchain. So that's why it costs so much money on Ethereum today. It costs $50 a transaction because there's so much demand. People want to post Ethereum transactions that they have to outbid each other to post their own transaction. It's because Ethereum can only handle about 10 transactions a second. This is getting to where Ethereum sits in the trilemma.
Yeah.
So the trilemma, Ethereum chooses decentralization and they choose security. They're sacrificing scalability.
Well, let me ask you this question. For my friends, again, right? Bring it back to my friends who are on Coinbase for the first time. They look at Ethereum and they ask me, well, Katherine, like, who runs Ethereum?
It's a good question.
So this is me kind of bringing this back to decentralization and what it means specifically on the layer one side.
Yeah. Well, I mean, I would say that the people who run Ethereum, because it's decentralized, they've prioritized that. It's independently anybody who chooses to run what's known as an Ethereum node. We're not going to get technical here, but if you're running a node, and especially a mining node, you're basically processing transactions for the Ethereum network. Anybody can do this. Because they focused on decentralization, it doesn't take a supercomputer to run. And so the people who run Ethereum could be you and me. We could run that node. Yeah. We could process those transactions. As it turns out, it ends up just being a collection of, a few thousand people. I actually don't necessarily know the exact number. It might be 50,000 or more people that are actually running these nodes for Ethereum and processing transactions.
So just to bring it back to your Visa example, the reason why it's hard for Ethereum to run more than like a handful of transactions at a time, and the reason why it's hard to do that is because instead of Visa as the central like company that runs your credit card payments and approves it, the Ethereum network runs probably, if not more, data, right? But instead of having one company whose whole job it is to approve this, it is all in the hands of anyone who owns or runs a particular Ethereum like computer, right? A computer that's dedicated to running Ethereum storage and data. And the reality of it is if there's so many people around the world doing it, it's just really hard and takes time. And the other really important thing is that it can't be reversed.
Right. This is the security aspect.
Right. So there's very little room for error. So if you want to run a perfect set of data every time, it's going to take time. And if you want to do it among a lot of people, then it's also going to take time, right? So when we talk about scalability, when we talk about decentralization, that's really what we mean.
So there's clearly a challenge with Ethereum, right? It doesn't scale. And so at least doesn't scale today. It hopefully will in the future. We'll talk about some of the ways it's addressing this. And there are some very promising things happening called layer twos, rollups, right? More buzzwords, yay.
But for now, I want to talk about where some of the newer layer ones maybe potentially fill some of those gaps that they see Ethereum kind of just like not there yet today.
One of the things these other layer ones are addressing is they're actually addressing the blockchain trilemma. They're saying, hey guys, we've probably solved this. We have a way to scale. We have a way to make it decentralized. We have a way to keep security high. And so they're postulating ways this might occur, right?
Yeah.
And TBD, I think it's too early to say if they've actually solved this or not. There's oftentimes, a little more centralized than they might claim to be or something. But they say, hey, we're going to make a scalable ecosystem.
Right. Yeah. So, for example, there's a particular faction of layer one blockchains that are aimed at being faster and cheaper.
Yep.
Right. Their whole thing is faster, cheaper, faster, cheaper.
I'd say that's probably the biggest shtick they've got going is they say, look, we're fast where Ethereum isn't. Our transactions cost 20 cents where Ethereum costs 50. And my God, is that a good shtick? Because you can't actually have, if applications running on a decentralized network or whatever, you can't have this utopian vision of the future if your transactions cost $50 a pop.
Yeah.
That prices out everybody.
Which is a good criticism, right? I think one of the biggest criticisms in Ethereum in recent years is as the adoption has really spread mainstream, it's just become so slow and so expensive. Yeah. And so this obviously creates good opportunity for other blockchains to come in to try to improve on that.
Absolutely. Yeah. What other things are these other layer ones improving on?
Another one that we're seeing is really around the base functionality of the programming language.
Yeah.
And like what it allows for the blockchain to do really well. So one of the examples is Flow blockchain launched, I think 2 years ago.
Yeah.
And they're basically optimizing strictly for NFTs.
Yeah. So you see some blockchains that are trying to cater to specific communities. Each blockchain has a programming language that they run. The Ethereum programming language is known as the Ethereum virtual machine. It's simply a way that the Ethereum blockchain processes code. Ethereum also has a few higher level programming languages like something called Solidity, which looks a little bit like JavaScript, and it compiles into the EVM. Some other blockchains, this is very technical, right? But some other blockchains are trying to improve on this by offering other types of programming languages that can have added functionality, they can cater to specific communities, they can potentially attract current developers. So I'll parse this out a little bit here, right? So the Flow blockchain, they're focusing on NFTs. Their programming language can be kind of, specifically built for the NFT universe, right? Other blockchains are actually trying to create programming languages that are identical to current programming languages. So suddenly, honestly, if you want to onboard to blockchains today as a developer, you have to learn Solidity. You have to learn Ethereum's programming language.
Yeah.
And that's a huge burden to do. You have to go out there and learn this whole new thing, right?
Like, who really is the backbones of all of these highly technical protocols? It's software engineers.
Yeah, it is.
So part of it is also thinking about, can you attract existing software engineers to build on your particular platform, right? So I think another, and this is what I meant about base functionality of programming language, it's also, is it easy for someone who currently codes in the existing traditional, software programming languages as we know it, and is it easy for them to port it over onto whatever specific blockchain or whatever specific layer one? Yep. And I think that really also affects the developer activity on it, right? So like one of the metrics I know that I consider when I kind of look into a new layer one is how much developer activity is there on this particular layer one blockchain.
Yep. And their programming language of choice, the layer one, the blockchain's programming language of choice affects that. Yeah. And so some are trying to improve or, they're different from Ethereum in that regard as well. Maybe one other thing that other layer one blockchains are trying to do differerently is governance and social structures. So somebody else in blockchain land comes up with this amazing new thing that can do X, Y, Z. Tezos can be like, cool, I'm going to take that too and put it into Tezos because they built in a governance structure that let them amend and update their blockchain in a really clever way. But what are the challenges they face when they're trying to build it out?
You mean not every single blockchain can be perfect?
Yeah, it's a trilemma after all. Yeah. There's always trade-offs, right?
All right, so let's talk about the trade-offs.
Yeah. One of the biggest trade-offs that I see is there's just a technical challenge, to be honest. While they claim that they might be able to solve the trilemma and be scalable and decentralized and secure, the reality is when you peel back the curtain a little bit, they're probably making trade-offs somewhere.
Everyone needs to sleep.
Yeah, exactly. I can't actually, make the claim for all the blockchains because I'm not deep in all of them. Some have done some really groundbreaking research and development, and there are really promising things that are solving for scalability while also improving decentralization. But I'm not convinced that there's a silver bullet. So there's generally always a trade-off technically somewhere. There's not a silver bullet to these things. So that's one trade-off. What's another one?
I think another one is probably what I touched on earlier around attracting developers.
Definitely.
So again, one of the most important things to really suss out like how alive your blockchain is how much activity is on it, right? Like how much building activity is on it. So theoretically, the more building activity is on your blockchain, the more alive and the more valuable it is. And that's why I think Ethereum till this day holds such a strong position in people who are new to crypto and want to build, because I think Ethereum has such a vibrant developer community on it, right? Which
Absolutely.
Also means like, and listen, like if you're a software engineer, a lot of what you do is like Q&A. You're just basically asking Google if somebody knows how to do this. And so that's a really, I think, core part to the developer experience.
Yeah.
And so if you have a community where it's also other developers who have either like solved the problem that you're working on or you're in it together, that is a sense of belonging. That is a sense of community.
How do you actually gain a viable ecosystem? Well, first off, you need developers to build on it because developers bring the apps. Without apps, you can't get users to be on your blockchain. So you kind of need developers. How do you get developers? Well, they look for users too, right? So it's a chicken and egg problem. Developers want to build where the users are. This is why Ethereum has such a strong head start. They have all the developers, they have all the tooling, they have all the infrastructure needed. Other blockchains have to compete with that somehow.
I want to address another really important challenge that a lot of layer one blockchains are facing, which is around security. Sometimes when you deploy something into the wild or release it on mainnet, sometimes the bugs come to you, right? It's just impossible to catch all of the bugs when you're testing for it. So a lot of where I think the new blockchains struggle with is just lack of years of being out there.
Yeah, I think you're 100% correct.
So what do you say to someone who comes to you and is like, I am really interested in building on XYZ, but I really worry about these like hack headlines that I read about? Like,
Yeah.
what do you say to that?
Yeah, I mean, I think there's just going to be a fitness function that happens here. It's a fancy word for saying there's going to be evolutionary dance that occurs, where new blockchains are going to release their code. They got to start from somewhere, right?
Yeah.
They're going to be brand new. They're going to be relatively untested. They're going to have auditors look at it and give it like the rubber stamp of approval. But we don't really know how secure it is until it's in the wild, until it's holding a lot of money, until anybody in the world can look at it and see if there's an exploit somewhere, right? So the reality is you kind of have to start from somewhere. Start small. Have an alpha version, have a beta version, build things up gradually, adding more money and more value over time, so that if there is a bug or an exploit, you're kind of capping the losses. And then as time goes on and on and on, well, you've had a longer period of time where you can be more and more convinced that it's secure because everybody's been looking at this thing for years now. Oh, and it's holding millions and millions of dollars. Okay, cool. That honeypot's large enough. It's been around long enough. We can kind of stand on it now. We can trust it a little bit more. I think for the first time, Ethereum is hitting this boundary, right? We're like, oh, it's been around for, at scale, it's been around for about 4 or 5 years now. And it's been holding hundreds of millions of dollars. I mean, the flip side to this is, why would anybody build another blockchain ecosystem? Because Ethereum is so expensive. It doesn't scale.
Yeah.
If you're a developer and you want your users to perform microtransactions, that cannot live on Ethereum. It's too expensive on Ethereum. You have to go to another ecosystem. So there's an interesting dynamic here where it's like, look, Ethereum is awesome. It has all these moats. It has such a powerful ecosystem.
So now we're flipping it actually to like a builder's perspective. Like as a software engineer who wants to build applications in the blockchain world, how do you go about choosing where you want to build it on? It again touches the trilemma, but I think from a slightly different angle, which is that it goes into what are you building and what is its core purpose? And like among the 3 trilemma vectors, which one are you more okay with giving up something on, right?
Yep.
Making some trade-off on. So as you mentioned earlier, if your application is very specific to making a ton of microtransactions, maybe in this case, you would sacrifice a little bit on security or sacrifice a little bit of decentralization and go to another layer 1 blockchain that is better suited to huge volumes of throughput.
Yep, exactly. And there's almost like a psychological element here too, right? Because even though Ethereum has this huge moat, other blockchains have people that look at the advantages that that specific blockchain is building on. Oh, this blockchain is going to be fast. It's also going to do X, Y, Z. It has all these cool properties. Oh my gosh, look how cool this is going to be when it hits scale. And so a lot of these other blockchains actually do have users that are waiting to use whatever applications are built on them. And so if you're a developer, it's not that you don't have any users right away. You actually kind of do. You have a stable group of people that you can tap into that might be exciting.
Yeah, well, I think my personal thesis on that is that I don't think the users care. So like, yeah, it's a chicken and egg problem, but not really, because the user's not going to actually care what layer 1 blockchain you're building whatever application on. They just care about the usability of it. With every year, I think we're seeing more talent come into crypto. And with every year, you have more choices. So now I think actually for the first time, we have seen other layer 1 blockchains actually launch. And so for the first time, like builders actually have really viable choices beyond Ethereum to build on other blockchains. And so I actually think like we're going to start to see really interesting convergence of types of application on whatever blockchain. We're going to start to see that natural alignment in the coming, 3 to 5 years.
Yeah, it's going to be a really interesting, exciting time, frankly.
So obviously competition between layer 1 blockchains are heating up. Maybe we want to think about how Ethereum can cater to applications that just run a ton of volume through it.
Yeah. How does Ethereum address the growing number of other blockchains that are solving for scalability? Quite clearly, the only thing holding back Ethereum from success, at least in my opinion, is their scalability. So if they can solve that nut and keep their moat, boy, that'd be powerful, right? So how are they doing it? What are they doing?
So I think at this point, I feel comfortable moving on from layer 1s.
Yeah.
And we're going to move on to layer 2s. A layer 2, as the name suggests, most likely builds on top of a layer 1. Duh. And when I say layer 2, though, I think what is commonly out there is actually layer 2 solutions to the Ethereum blockchain. And so you actually had a really good example with bar tabs. I really liked that when talking about layer 2s.
Yeah, this bar tab example is actually borrowed from the Bitcoin community, the Lightning Network. But one way to think about how layer 2 systems work is, hey, if you go to the same bar every day and you buy a beer every day or whatever, well, why would you settle that transaction every single day? Instead, you could just run up a tab of 100 beers or what? That's a lot, but a lot of beers, right? And then settle it all at once, maybe once a week, maybe once a month, whatever it is. And so in that sense, you're building a tab of transactions that are not being settled, but finally are settled at some regular interval. So if we want to think about how to scale Ethereum, well, the Ethereum blockchain exists. It's out there. It's really, really hard to upgrade the base Ethereum machine to be scalable. You're basically swapping the engine out of a car that's already going 100 miles an hour. Like scary, dangerous, oh my God, hard. So a better scaling philosophy tends to be, hey, why don't we have a second ecosystem that sits on top of Ethereum that runs up huge bar tabs and then periodically settles to the main Ethereum blockchain. So the main Ethereum blockchain still can handle those settlements because each settlement, basically represents thousands of transactions. But in that way, we can increase our scalability and throughput on Ethereum just by moving those transactions to a layer above, a layer 2 ecosystem.
Yeah. So layer 2s also have a name I really like. It's called rollups. And I kind of like that because it literally is like, it's very visual, right? So basically what happens is instead of Ethereum, right, which is my dear old slow beloved computer who literally cannot handle all the stuff I want it to run. So if you think about layer 2s, it's like I buy a little component to put on top of my slow beloved machine, and this little component just like rolls up all the data that's supposed to actually run through my old slow machine and actually runs it on this like top new shiny little component. And then once it runs it and okays it, it then sends it back to the machine as like a state of okay. And it just like takes it to go. Yeah. So like you can think about it as like a little component that rolls up all the complicated high volume stuff and just like sends it back to the old machine and it's like everything's gonna be okay. So that's a highly
we're very technical here.
Yeah, that's a super high level explanation, but I think it makes sense, right? So obviously it's still very new, but the trade-off, for example, is how does Ethereum, right, the old beloved machine, just like know that everything that the layer 2 is telling it is true? And so there are different solves to it as well.
So to step back a second, we've got a bunch of layer 1s that are trying to improve Ethereum or make it different or better somehow, mostly around scalability. Ethereum is saying, cool, we got to make our system scalable as well. How do we do that? Okay, cool, we got this layer 2 system. What are the trade-offs though when you move to a layer 2 system versus a layer 1 system? What are you giving up when you do that? The answer is, you lose composability. So if you put all of your transactions onto a layer 2 ecosystem that then periodically settles with the layer 1 base Ethereum blockchain, you can't write applications that interact with other applications. So in other words, I can't write a transaction that swaps tokens on Uniswap and then deploys them into Compound because I'm on a layer 2 system. I'm not connected natively to the layer 1 ecosystem. So you lose some usability when you adopt this model. The way you'd get around that is if you just have every application running on one single rollup, on one single layer 2, and then you gain composability back. But you would never have composability between the layer 2 and the native Ethereum ecosystem. And so you end up kind of fragmenting your universe a little bit.
Yeah.
And these are also, by the way, like kind of like theoretical things that people have postulated in technical research and development land. We don't really know if there's going to be some novel silver bullet solution to composability. We postulate there isn't, but we're still kind of early in the game. But these are kind of some of the trade-offs that the ecosystem is facing around how to scale blockchains. Either you do a layer 1, you gain all those effects, but you have to build it all yourself, or you do a layer 2 to Ethereum and you scale Ethereum, but you lose something in the process. You lose composability.
I think in the long run, scaling solutions work if your sole goal is how do I build something on Ethereum and just make it faster and cheaper, right? And I think it serves its purpose well. Where I think we are very kind of TBD and waiting to see on is if it becomes too single use case focused and like can no longer actually take advantage of the fact that you're building on a very vibrant layer 1. And so I think working on how to communicate when you're using different technologies and different rollups and different layer 1s. How do you roll it all back together? I have no idea.
Yeah, we're very early. That actually might be a good segue to think about just the meta question. Long term, how do we think about the future? Which one of these ecosystems is going to win? Are there going to be many winners? Going to be one winner? How do we think about how to evaluate the viability of different ecosystems? If we put on our investor hats, what are the things we look for? And you're touching on one there, right? It's actually around this idea of, do we think there's going to be many winning blockchain ecosystems, many layer 1s? Do we think there's going to be many different rollups that are more application specific and do one thing and one thing very well? Or do we think there's just going to be a handful, 2 or 3 main large blockchains that have gained all the scale and all the throughput and everything happens on those?
I remember when just a few years ago, the sole debate was, is it one chain to rule them all, or are there going to be different chains? And I think what we've already seen, and by the way, when I say chains, I just mean layer 1s. And what we've already seen in just the past 2-3 years is that actually the answer to that question is that it's going to be a multi-chain world. And I don't think there's anything wrong with saying that. Like Ethereum is still going, as of now, it still owns a lot of the developers, but there's some really strong contenders, right? There have been solutions at trying to solve the problem for Ethereum, but at the same time, so much innovation is happening with other layer 1s that I don't think it's necessarily wrong to say that right now where I'm seeing a lot of the companies building on is actually no longer, the default answer is no longer we're going to build on Ethereum.
Yeah, it's not. We've kind of noticed that in ventures. I mean, we're seeing a lot of companies and many more are now building on other blockchains.
Yeah.
We've actually also seen this in the past with other technologies. The example that I kind of like to point to sometimes is the internet. If you look back, roll back the clock to like 1995 or whatever, you had kind of a single server model where one server would handle hundreds of different web pages. And if any one web page popped off in popularity and got a bunch of hits, all the other web pages suffered as a result because that one server got overwhelmed. That's the exact analogy you have today with Ethereum. If one smart contract, if one NFT drop, if one thing pops off, boom, transactions skyrocket, the entire Ethereum ecosystem kind of suffers as a result, right? And so the question is, well, I mean, what did the web model do? The web model, they switched to, hey, single dedicated servers per web page. And then each one is responsible for its own destiny. Now, the difference here, though, is in the internet example, it's very easy for these other servers to talk to each other. They can still be, quote, quote, composable. You can still kind of build and interact with each other in a very seamless way. If you try to do the same model on blockchains, and you have one blockchain per application, you can't talk to other blockchains in a very seamless fashion because there's money at stake. There's value that needs to be transported across blockchain, and that's hard. It takes time. It's a very difficult, challenging problem. And so you lose that ability to communicate.
Yeah. And well, I think there are interesting solutions, and I don't think we have time to go through them today.
Probably not.
but basically, what I want to make clear is everything that we're talking about today and all the limitations that we talk about, there will be solutions to all the limitations we talk about, right? So where I'm sitting, like I'm highlighting the trade-offs as a kind of like a understanding of where our current state is today. But what makes me really excited is actually noticing that with every trade-off that I mention or every limitation I notice, there's almost like 10 teams at the same time working to solve like one specific problem, which makes it really exciting because then, it really gives me faith that the space is really going somewhere.
We're doing new things. We're hitting brand new challenges we've never faced before, and we're collectively trying to solve them. And the thing that we're trying to accomplish is, hey, anybody can interact. This is a decentralized movement. These are applications written for anybody in the world. It's a global, free economic system that we're trying to create here. And that's so powerful and so cool at the end of the day. But look at all the nitty gritty challenges that have to be solved.
Yeah.
I'm with you. I believe that we're going to get there. We're going to solve it.
Yeah.
I don't know the path to do it. It's going to be hard and bumpy and rocky. But eventually we'll get there.
I just can't believe for a second there I was more optimistic than you. That's like a personality reversal there.
Yeah. What happened? Huh? Yeah.
Yeah. I mean, look, I think the main takeaway that I really wanted to get to today is that now there's a good understanding of layer 1 blockchains. Now there's some understanding of layer 2s, which is just only a small subset of a solution of a particular layer 1 blockchain, right? But to the extent the next time you open the Coinbase app and you actually go through some of the descriptions, you can actually start to parse out what these different assets or what these different protocols mean.
If it's a layer 2, it's a rollup. It's connected to Ethereum. If it's a layer 1, it's its own blockchain ecosystem. It's trying to recreate and improve on things. Mm-hmm. And we didn't even get to touch on all the different tokens that exist.
Yeah.
Because boy, the space is complicated, but yeah.
Yeah, but I think this is good enough. And I think this is good enough where I feel okay stopping it on this chapter. And I think we should have more to come. But for today, I feel good about giving the framework.
Yeah. Do you think you can tell your friends, hey, listen to this podcast and you'll get a better sense for it?
I hope so. That's a wrap for today's Around the Block podcast by Coinbase. We tried something new today. We didn't bring in a guest, but we really want to know what other questions you have about the blockchain ecosystem and what confuses you when you're trying to dig deeper, when people tell you to do your own research, like where else are you trying to learn more on? I think that would be really great for us to hear from you and really help us help you. So don't forget.
You got, yeah.
So don't forget to listen, subscribe wherever you're getting this, and leave us a comment.
And don't forget, we have a landing page, coinbase.com/aroundtheblock, and hit us up next week for more.
Awesome. See you guys next week.
Today's conversation is for informational purposes only and does not constitute legal or investment advice. Actual results may vary materially from any forward-looking statements made and are subject to risks and uncertainties.